Space. Chapter 89. On the level of our everyday observations, space and time seem to be the obvious, the common, and the connected properties of physical things. We distinguish things from one another by their position in space, as we mark happenings by the date of their occurrence. The where and when of a thing is often used to identify it, for it is generally agreed that two bodies cannot occupy the same place at the same time, and that at the same time two distinct places cannot be occupied by the same body. According to a theologian like Aquinas, these limitations of space and time apply even to bodiless things, i.e., to angels. An angel and a body are said to be in a place, he writes, in quite a different sense, whereas a body whereas a body is in the place which contains it. An angel is said to be in a corporeal place by application of the angelic power, not as being contained, but as somehow containing it. It follows, nevertheless, that at a given time, an angel is not everywhere, nor in several places, but in only one place. Nor does the incorporeality of angels permit more than one angel to be at the same time in the same place, according to the manner in which an angel is at a place by the action of his power. There can be only one angel in one place, Aquinas declares, even as there can be only one body in one place at a time. Location, or position in space, and spatial relationships such as higher and lower, nearer and farther, are so familiar and intelligible that they provide terms of reference whereby men speak metaphorically of the moral hierarchy and spiritual distances. The whole of Dante's Divine Comedy, for example, involves a spatial metaphor which sets forth the gradations of sin and the degrees of blessedness in terms of places beneath the earth and in the heavens above. As he mounts from sphere to sphere in paradise, Dante meets Piccarda Donati in the heaven of the moon. She explains to him that this place, which appears so far down, is assigned to those who have violated their vows in some particular. Dante wonders why she and the others desire a more exalted place in order to see more. Piccarda replies, "Brother, virtue of charity quiets our will and makes us wish only for that which we have, and quickens not our thirst for aught else, so that as we are from seat to seat throughout this realm, to all the realm is pleasing, as to the king, who enwills us with his will, and his will is our peace." This speech of Piccarda's makes it clear to Dante how everywhere in heaven is paradise, even if the grace of the supreme good does not there rain down in one measure. These different measures of beatitude in the diffusion of God's love and light are represented by the celestial spheres from the earth adjacent moon to the crystalline heaven, the outermost bound of the physical universe, of which Dante says that it has no other where than in the divine mind. When the whole expanse of physical space, or the boundary of the universe, is considered, Newton, no less than Dante, conceives the omnipresence and eternity of God as that which somehow encompasses all space and time. God is not duration or space, Newton writes at the end of the Principles, but he endures and is present, and by existing always and everywhere, he constitutes duration and space. In the concluding queries of the Optics, Newton appears to think of infinite space as the divine sensorium in which all things are at once present to God, who, being in all places, is more able, by his will, to move the bodies within his boundless uniform sensorium, and thereby, by form and reform, and thereby to form and reform the parts of the universe, then we are by our will to move the parts of our own bodies. The physicist does not have to turn theologian, however, to be confronted with the mysteries of space, even without the modern complications of the relation of its three dimensions to time as a fourth dimension. The physical concept of space raises difficulties for analysis. In the tradition of Western thought, conflicting definitions of space seem to result from a fundamental difference in the object being defined, whether it is an inseparable property of bodies, perhaps even identical with uniformed matter, or a reality apart from the bodies which move and have their being in it. Sometimes this difference is signified by a difference between the meaning of the word place or extension and the meaning of space. It appears also to be involved in the contrast between filled space and empty space, i.e., the void or vacuum. And it bears some relation to Aristotle's distinction between space and place, and to Newton's distinction between absolute and relative space. The controversial character of space in physical theory may be appreciated in terms of these oppositions in meaning and the issues which they raise. In addition, physical theory is confronted with the problem of action at a distance, i.e., action through a void or through an ethereal medium. The problem of the infinity of space, or the question of a bounded or unbounded universe, and the distinction between one physical space and the variety of geometrical spaces. Space, which at first seems easily apprehended by sense and susceptible to measurement, becomes, upon examination, so subtle as to be almost a vanishing object. Reason finds it difficult to say precisely what space is in itself, and how it is related to matter and motion. Even the familiar space of ordinary sense perception seems to have its puzzles. A psychologist like James is concerned with how the different fields of touch, vision, and hearing coalesce to form the single space of our experience. And in dealing with the process by which we learn to perceive the spatial manifold of positions and directions, he cannot avoid the issue of innate as opposed to acquired space perception. Plato's theory of space is set forth in the Timaeus as part of the likely story which Timaeus tells about the production and constitution of the universe. These sensible things which come into being and pass away are, according to him, patterned after the eternal forms. To the eternal patterns and their copies in the world of change, Timaeus finds it necessary to add a third factor in order to account for the physical elements and their generation. This factor, he says, is difficult to explain and dimly seen. It is the receptacle, and in a manner, the nurse of all generation. In contrast to the elements, which are perpetually changing into and out of one another, the receptacle never departs from her own nature, and never in any way assumes a form like that of any of the things which enter into her. The forms which enter into and go out of her are the likenesses of real existences modeled after their patterns in a wonderful and inexplicable manner. Timaeus distinguishes the three principles as that which come to be and passes away in the process of generation, that in which the generation takes place, and that which the generated thing resembles, and which is its source. He likens the receptacle or receiving principle to a mother, the source to a father, and the intermediate nature to a child, and adds that if the model is to take every variety of form, then the matter in which the model is fashioned will not be duly prepared, unless it is formless and free from the impress of any of those shapes which it is hereafter to receive from without. Wherefore, that which is to receive all forms should have no form. The mother and receptacle of all created, visible, and in any way sensible things is not to be termed earth, or air, or fire, or water, or any of their compounds, or any of the elements from which these are derived, but is an invisible and formless being which receives all things and in some mysterious way partakes of the intelligible and is most incomprehensible. This third factor, which Timaeus sometimes calls matter as well as receptacle, he also sometimes calls space. When matter and space are identified with each other under the conception of a receptacle for the forms, they have the characteristics of being absolutely formless and imperceptible to the senses. Nor are they, as are the forms, genuinely intelligible to reason. The third nature, which is space and is eternal, Timaeus says, admits not of destruction and provides a home for all created things, and is apprehended without the help of sense, by a kind of spurious reason, and is hardly real, which we, beholding as in a dream, say of all existence that it must of necessity be in some place and occupy a space, but that which is neither in heaven nor on earth has no existence. The precise meaning of this conception of space is difficult to determine. Does it, for example, find an echo in Plotinus's statement that space is a container, a body? It is the home of such things as consist of isolated parts. But he also says that space, in a strict sense, is unembodied and is not itself body, and that body is not a void, but rather that the void must be that in which body is placed, seeming thereby to imply that space is essentially the void. The statement in the Timaeus that there can be no such thing as a vacuum may apply only to the filled space of the created heaven and earth. May it not also be said that space is a void when it is identified with the formless matter of the receptacle prior to creation? This raises further questions. Is the receptacle space or matter? And is the conception of space in the Timaeus rightly interpreted by Aquinas in commenting on Augustine's reading of the earth was void and empty in Genesis 1, verse 2? Augustine holds that By the word earth in this passage, formless matter is to be understood. But of its formlessness, Aquinas writes, the earth is said to be void and empty, or invisible and shapeless. And he adds that that is why Plato says matter is place. However, these questions are answered. One thing seems to be clear. Space, functioning as receptacle, can be identified only with matter devoid of form, not with the matter of three-dimensional bodies. The relation of space to matter seems to be differently conceived by Descartes. Space is for him not an antecedent principle involved in the original production of sensible things, but rather, as the extension of bodies, it is inseparable in existence from them. It is a property which signifies the essence of material substances, as thinking signifies the essence of mind or soul. By extension, Descartes writes, we understand whatever has length, breadth, and depth, not inquiring whether it be a real body or merely space. Period. Nevertheless, he goes on to say that by extension we do not here mean anything distinct and separate from the extended object itself. Descartes considers the significance of three statements. Extension occupies place, body passes extension, and extension is not body. The first statement, he thinks, means no more than that which is extended occupies place. The second statement seems to imply that the meaning of extension is not identical with that of body, yet, Descartes insists, we do not construct two distinct ideas in our imagination, one of body, the other of extension, but merely a single image of extended body, and from the point of the view of the thing it is exactly as if I had said, body is extended, or better, the extended is extended. Finally, in the statement that extension is not body, the word extension, according to Descartes, expresses a purely abstract conception, nothing which in itself has any sensible reality. So far as its existence is concerned, the thing conceived as extension cannot be separated from body. Those who think otherwise, Descartes asserts, are involved in the contradiction of saying that the same thing is at the same time body and not body. The point is summarized in his Principles of Philosophy by the statement that the nature of matter or of body in its universal aspect does not consist in being hard or heavy or colored, but solely in the fact that it is a substance extended in length, breadth, and depth. But it may be asked, are the dimensions of a body the same as space? Descartes replies that the same extension, which constitutes the nature of a body, constitutes the nature of space. Not only that which is full of body, but also of that which is called a vacuum. If there were a vacuum or empty space, extension might be separated from body. This Descartes flatly denies. As regards a vacuum, in the philosophic sense of the word, i.e., a space in which there is no substance, it is evident that such cannot exist, because the extension of space or eternal internal place is not different from that of body. And even when we take this word vacuum in its ordinary sense, Descartes goes on, we do not mean a place or space in which there is absolutely nothing, but only a place in which there are none of those things which we expected to find there. These points made in the Principles confirm the identification of three-dimensional space or extension with body which appears in the Rules. They seem to be further confirmed in the discourse by the reference to a continuous body, or a space indefinitely extended in length, height, or depth, which is the object of the geometricians. Descartes does not, however, neglect the distinction between space as the extension of body and place as the position one body occupies in relation to another. According to common usage, he says the word place signifies that in virtue of which a body is said to be here or there. He objects to those who, like Aristotle, mean by place the surrounding surface of a body. Local motion or change of place is not, he argues, a change in the body's surrounding surface, but a change in its relative position. It is place rather than space which Aristotle seeks to define, and place in the sense of the circumference of a body rather than its position in space. He rejects the notion that place is the extension of a magnitude, for that would, he thinks, identify it with matter. Place belongs to body, not as matter or a property of matter, but as its boundary. It is, Aristotle writes, the innermost motionless boundary, a kind of surface, and, as it were, a vessel, i.e., a container of the thing. This boundary is itself made at the surface of a body by a surrounding body or bodies. If a body has another body outside it and containing it, Aristotle writes, it is in place, and if not, not. The consequences of this conception of place are, first, a denial of space in the sense of void or empty place. Since place is always coincident with the thing contained or bounded. Second, a denial of any infinite place, since that would presuppose an actually infinite body. To Aristotle, an impossibility. And third, the conclusion that the whole universe itself does not have a place, for outside the outermost heaven which bounds the world, there can be no containing body by which the universe is bounded. Aristotle explains that by heaven he means the extreme circumference of the whole, a whole composed of all natural perceptible body. The two words which Einstein uses when he discusses the possibility of a finite and yet unbounded universe seem to apply to Aristotle's conception of the world, finite in body or matter, yet unbounded, i.e., without anything outside itself to determine or define its boundary. Aristotle's view of the world seems to be directly opposed to that of the ancient atomists. For them, the whole of matter is discontinuous, existing in indivisible units or atoms, each of which is a plenum, that is, a unit of matter absolutely continuous, without void in it, but between which there is void or empty space. For Aristotle, the material world as a whole is a plenum, i.e., continuous body, without void. Hence, if by space is meant not place but void, a bodiless interval between or within bodies, there is no space. Aristotle considers the arguments of Democritus that without void, local motion would be impossible. But he thinks there is no necessity for there being a void if there is movement. Following Democritus, Lucretius gives another reason for positing void or empty space, as the indivisibility of the simple bodies or atoms consists in their absolute solidity. Their lack of void, so the divisibility of composite bodies derives from their being constituted by both atoms and void. Wherever space lies empty, which we call the void, Lucretius writes, body is not there. Moreover, wherever body has its station, there is by no means empty void. Therefore, the first bodies are solid and free from void. If there were nothing which was empty and void, the whole would be solid, unless there were bodies determined to fill all the places that they held. The whole universe would be but empty void space. For Aristotle, in contrast, the divisibility of matter seems to depend upon its being continuous. On his view, the composite body, constituted by atoms, separated from one another by void, is not divisible, but is already actually divided, whereas the very thing which Lucretius regards as indivisible, because it is continuous, the voidless atom, is for Aristotle divisible. To call an atom divisible is, of course, to deny that it is atomic, or, in the language of Lucretius, an uncuttable bit of solid singleness. Thus, diametrically opposite theories of space and place seem to be connected with opposite theories of matter or body. Space as the empty interval, or void, between solid bodies goes along with atomism, whereas place as the boundary of the containing body at which it is in contact with the contained body goes along with the theory of the world as a material plenum. The atomic theory and the plenum theory are opposed in one other fundamental respect concerning space. According to Aristotle, the impossibility of an actually infinite body makes the largest place finite. According to Lucretius, the infinite number of atoms requires an infinite space. Asking whether the void that we have discovered, or room, or space, is altogether bounded, or spreads out limitless and immeasurably deep, Lucretius answers that the whole universe is bounded in no direction. His argument seems to be like Aristotle's, for an unbounded universe, since there can be nothing outside the whole sum, he writes, it lacks, therefore, bound or limit. Since there can be nothing outside the whole sum, it lacks bound. Yes, but what if nothingness is something? It's like that Star Trek episode where they end up outside the universe. Where the laws of reality just start falling apart. Since there can be nothing outside the whole sum, he writes, it lacks, therefore, bound or limit. But where Aristotle's meaning seems to be that the universe has no place, since all places are inside it, Lucretius appears to mean that empty space extends infinitely in all directions. Modern atomists like Newton and Locke hold a theory of space which accords with the view of matter existing in discontinuous units separated by intervals of emptiness. Newton's distinction, for example, between absolute and relative space acknowledges a space that is relative to bodies, but also affirms an absolutely independent space, which has being and separation from matter or bodies. Absolute space, in its own nature, without relation to anything external, he writes, remains always similar and immovable. Relative space is some movable dimension or measure of the absolute spaces which our senses determine by its position to which our two bodies, and which is commonly taken for immovable space. As for place in distinction from space, Newton holds, that is, a part of space, which a body takes up, and is according to the space either absolute or relative. In opposing Aristotle's view, he adds that place is not the situation, nor the external surface of the body, for the places of equal solids are always equal, but their surfaces, by reason of their dissimilar figures, are often unequal. Locke also distinguishes between space and place, the one consisting in the relation of distance between any two bodies or points, the other in the relation of distance betwixt any thing and any two or more points, which are considered as keeping the same distance one with another, and so considered as at rest. With this conception of place, he holds in apparent agreement with Aristotle that we can have no idea of the place of the universe, though we can of all the parts of it. Yet he goes on to say that what lies beyond the universe is one uniform space or expansion, wherein the mind finds no variety or marks. This seems to indicate that Locke's idea of space, like that of Lucretius, conceives an infinite void. Those who assert the impossibility of space existing without matter must, he writes, make body infinite. Well, what else did Genesis say? Or maybe this was the New Testament. Something about light came into the world and the darkness comprehended it not. I feel like that's relevant. Infinite void, those who assert the... This seems to indicate that Locke's idea of space, like that of Lucretius, conceives an infinite void. Those who assert the impossibility of space existing without matter must, he writes, make body infinite. Furthermore, those who dispute for or against a vacuum do thereby confess that they have distinct ideas of vacuum and plenum, i.e., that they have an idea of extension void of solidity, though they deny its existence, or else they dispute about nothing at all. For they who so much alter the signification of words as to call extension body, and consequently make the whole essence of body to be nothing but pure extension, must talk absurdly whenever they speak of vacuum, since it is impossible for extension to be without extension. For vacuum, whether we affirm or deny it, signifies space without body, whose very existence no one can deny to be possible, who will not make matter infinite, and take from God a power to annihilate any particle of it. Precisely because he thinks no one can affirm an infinite body, and because he conceives space to be a void distinct from bodies, Locke finds it necessary to affirm the infinity of space. I would ask, he says, whether if God placed a man at the extremity of corporeal beings, he could not stretch his hand beyond his body. If he could, then he would put his arm where there was before space without body. Furthermore, if it be possible for any particle of matter to move but into empty space, the same possibility of a body's moving into a void space beyond the utmost bounds of body, as well as into a void space interspersed amongst bodies, will always remain clear and evident, so that wherever the mind places itself by any thought, either amongst or remote from all bodies, it can, in this uniform idea of space, nowhere find any bounds, any end, and so must necessarily conclude it to be actually infinite. It may seem paradoxical that pure space existing without matter, is denied by one who also denies the existence of matter. When I speak of pure or empty space, Berkeley writes, it is not to be supposed that the word space stands for an idea distinct from or conceivable without body or motion. What is meant, he suggests, is merely that the resistance one body gives to another in motion is absent when space is relatively empty. But this is always relative. In proportion as the resistance is lesser or greater, Berkeley says, the space is more or less pure. There would be absolutely pure space only if all bodies, other than this own, were annihilated. If that, too, were annihilated, Berkeley concludes, then there could be no motion, and consequently no space. All these contradictions concerning space enter into Kant's statement of the first cosmological antinomy, in which the thesis that the world is limited with regard to space, and the antithesis that the world is infinite in space seem to be equally susceptible to proof, and so to disprove. Both alternatives violate our empirical concepts. If space is infinite and unlimited, Kant writes, it is too large for every possible empirical concept. If it is finite and limited, you have a perfect right to ask what determines that limit. Empty space is not an independent correlate of things, and cannot be a final condition, still less an empirical condition forming part of possible experience. For how can there be experience of what is absolutely void? But in order to produce an absolute totality in an empirical synthesis, it is always requisite that the unconditioned should be an empirical concept. Thus it follows that a limited world would be too small for your concept. Space itself, however, is for Kant not an empirical concept which has been derived from external experience. Rather, it is a necessary representation a priori, forming the very foundation of all external intuitions. And as Kant explains in his Prolegomena, it establishes geometry as an a priori science. Space is nothing but the form of all phenomena of the external senses. It is the subjective condition of our sensibility, without which no external intuition is possible for us. Nothing which is seen in space is a thing by itself, nor is space a form of things supposed to belong to them by themselves. The external objects which we perceive in space are nothing but representations of our senses, the form of which is space. So far as the experience of space is concerned, William James seems to take an opposite view. Time and space relations, he says, are impressed from without, and stamp copies of themselves within. To the Kantian theory that space is a quality produced out of the inward resources of the mind to envelop sensations which, as given originally, are not spatial, James replies that he can find no introspective experience of mentally producing or creating space. He proposes two other alternatives. Either, 1, there is no spatial quality of sensation at all, and space is a mere symbol of succession, or 2, there is an extensive quality, given immediately in certain particular sensations. The second seems to James best suited to explain the development of our perceptions of space, and he does not think it inconsistent with the a priori or non-empirical character of geometry, whose necessary truths refer to ideal objects, not to experienced things in physical space. The chapter on mathematics considers the the relation of the postulates of diverse geometries to the diversity of Euclidean and non-Euclidean spaces, such as that of the flat plane, the surface of a sphere, and the surface of a pseudosphere. Just as different parallel postulates select different spaces for geometrical construction, so a postulate like Euclid's concerning the equality of all right angles seems to assume a uniformity of space which permits geometrical figures to be transposed without alteration. If translation through space warped or magnified forms, James remarks, then the relations of equality, etc., would always have to be expressed with a position qualification added. Confronted with a variety of purely mathematical spaces, the physicist is concerned with the problem of which geometry is, as Einstein says, in correspondence with a real object, or true of the real world. According to the general theory of relativity, the geometrical properties of space are not independent, Einstein writes, but are determined by matter. It follows that our assumptions about the distribution of matter determine the character of the world's space. On the assumption of a world not inhabited by matter everywhere, in whose infinite space the average density of matter would necessarily be nil, Einstein says we can imagine a quasi-Euclidean universe, analogous to a surface which is irregularly curved in its individual parts, but by which nowhere departs appreciably from a plane, something like the ripple surface of a lake. But if the average density of matter differs from zero, however small may be that difference, then the universe cannot be quasi-Euclidean. It must be spherical or elliptical if the matter were uniformly distributed. But since in reality the detailed distribution of matter is not uniform, Einstein concludes that the real universe will deviate in individual parts from the spherical, i.e., the universal will be quasi-spherical, but it will be necessarily infinite. The nature of the actual space of the universe thus seems to be related to the issue whether physical as opposed to mathematical space is a void or filled with matter. Defining a vacuum as a space empty of all bodies known to the senses, Pascal insists that there is as much difference between nothingness and space as there is between empty space and a material body, so that empty space occupies the mean between matter and nothingness. Torricelli's experiments seemed to him complete proof against the disciples of Aristotle, for they upset the belief that nature abhors a vacuum. Gilbert's observations on magnetic influences, Newton's observations on the transmission of light and heat as well as gravitational pull, and Faraday's on electrical phenomena all seem to admit the possibility of action at a distance or through a vacuum. But the question remains whether the so-called physical vacuum is an absolute void or merely empty of all bodies known to the senses. Is not the heat of the warm room conveyed through the vacuum, Newton asks, by the vibrations of a much subtler medium than air, which after the air was drawn out, remained in the vacuum. And is not this medium the same with that medium by which light is refracted and reflected, and by whose vibrations light communicates heat to bodies? And is not this medium exceedingly more rare and subtle than the air, and exceedingly more elastic and active? And does it not readily pervade all bodies? And is it not, by its elastic force, expanded through all the heavens? Huygens also refers to an ethereal matter as the medium for the propagation of light. One will see, he writes, that it is not the same that serves for the propagation of sound. It is not the air. It is not the same air, but another kind of matter in which light spreads. Since if the air is removed from the vessel, the light does not cease to traverse it as before. But this ethereal medium, without which bodies would act at a distance upon one another, gravitationally, magnetically, electrically, through an absolute void, seems to have contrary properties. It is not only subtler than air, but as Newton suggests, it may be denser than quicksilver or gold, since planets and comets and all gross bodies perform their motions more freely and with less resistance in this ethereal medium than in any fluid, which fills all space adequately but without leaving any pores. And in still another place he asks, what is there in places almost empty of matter? And whence is it that the sun and planets gravitate towards one another, without dense matter between them? Whatever may be thought of the ether as a physical hypothesis, the problem still remains whether action can take place at a distance through a void, or must employ what Faraday calls physical lines of force through filled space. Faraday thinks the evidence supports the latter alternative for both electricity and magnetism. He quotes a letter from Newton to Bentley to show that Newton was an unhesitating believer in physical lines of gravitating force. In that letter, posthumously discovered, Newton says, that gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has, in philosophical matters, a competent faculty of thinking, can ever fall into it. What did he say? That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through with their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has, in philosophical matters, a competent faculty of thinking can ever fall into it. So he's saying that there's some sort of field connecting matter. Gravity is the proof of that. what appears to be empty space between two objects is not really that, because the gravitational force is apparent. Kind of occurred to me recently that gravity is kind of a comforting sensation. The feeling of being drawn to the center of the earth. It's quite noticeable, you know? Like if you were, like we are being pulled at all times, like a magnet to the surface of the earth. If you went up in space and floated around, you'd probably be like, you'd probably feel, I don't know, I think you'd miss being on the earth. You know, like you might not have anything else, but at least the earth loves you, constantly trying to pull you closer. Of course, if you fall from a great height, then you're not really gonna be too happy about the gravitational pull. Alright, cross it off the list. Whoops. Ready?